All right, hello, my his side classes. So this is the next video for our decalcification discussion. Okay, and in the last video, I already finished discussing the different factors that affect decalcification as well as the nitric acid formulations which are utilized for the decalcification. Okay, so for this video, I will be discussing the other acids which are utilized for decalcification. I will also be discussing other methods that you can perform in the laboratory to remove your calcium or your mineral deposits. Okay, so at the end of this video, I will also be talking about our post-decalcification treatment, and of course, the different tests which we can perform in order to determine if the decalcification process is already complete. Okay, so let's start with our formic acid. Okay, so formic acid, this can be utilized as a fixative and a decalcifying agent. Okay, so may I just mention also fixatives that can act as decalcifying agents. So in the laboratory, okay, in the laboratory, there are a lot of fixatives that we can use. Okay, so fixatives that can act as decalcifying agents, we have your carnoys, okay, carnoys and your bowens. All right, ayan. So formic acid, carnoys, and then bowens, all of this can act as fixatives and decalcifying agents, okay? So what are the characteristics of formic acid? Your formic acid, it is considered to be a moderate acting decalcifying agent. Since it is moderate acting, okay, as compared to your rapid acting decalcifying agents, it is considered to be gentler on tissues. Okay? The setback of using your formic acid, since it is moderate acting, is that it takes a longer duration for the decalcification process to be complete. Okay? So yun yung um, um, offshoot. Okay? The offshoot of it being a moderate acting solution or decalcifying agent. Okay? Number one, it's gentler on your tissues, which is actually an advantage. However, the disadvantage is that it takes a longer time or a longer duration for the decalcification process to be completed. For its application in the laboratory, okay, it is utilized for small and large pieces of bones and teeth samples. Primarily, it is utilized for for post-mortem research tissues. Okay, so again, take note that with the use of your formic acid, it will take a longer duration. Okay, and so the type of tissue sample that you should immerse in your formic acid, it should not require any urgency. Okay, it should not require you to provide an immediate result. Thus, pang post-mortem po siya. Okay, post-mortem research tissues. Okay, so the concentrated form of formic acid that is available in the laboratory is at 90%. However, take note that 90% it is too concentrated. So that's why we oftentimes make formulations or solutions out of the concentrated 90% formic acid. So there are two formulations or solutions that you can prepare from your 90% formic acid. So the first one, we have your aqueous formic acid. So aqueous formic acid, I think this is in your module. Aqueous formic acid, this is prepared using using formic acid, 90% formic acid plus your formalin or your formaldehyde. Okay. The other solution is your formic acid sodium citrate. Okay, so these are the two formulations of formic acid that we can use for decalcification. Okay. So as for the washing or the removal of your formic acid from your tissue samples, we oftentimes apply the concept of neutralization. So since you are using an acid, the reagent that we use in order to neutralize your formic acid, to remove it from your tissues would be or is your 5% sodium sulfate, which is an alkaline or a base. Okay, an alkaline or a basic solution. Okay. Another thing with your formic acid, remember that it is considered to be an organic acid. Okay, and as such, it is a weak acid. Okay, so kung weak acid siya, pwede ba natin siyang gamitin for your immunohistochemistry, immunocytochemistry? Yes, because it wouldn't have a significant effect on the destruction or on the loss of your antigenic surface markers or surface antigenic markers. Okay, we have your antigenic markers. Okay. Yes. So the next acid that we can utilize in the laboratory is your hydrochloric acid. Okay. So actually, your hydrochloric acid, it is a peculiar reagent that we use in the laboratory. Peculiar, peculiar or weird kasi nga it doesn't follow the general rules that we have when it comes to the use of acids in the laboratory. Okay. Your hydrochloric acid, it is considered to be slower as compared to the other acids that we use in the laboratory, but it causes greater distortion. If you are being observant when it comes to the acids that I have discussed previously, the more rapid your decalcifying agent is, the more destructive or the more detrimental it is to your tissues. Okay, that's the general rule. However, in the case of your hydrochloric acid, it is slow and it causes greater distortion. Okay? And another peculiar characteristic of your hydrochloric acid is that it it is capable of providing good nuclear staining. Okay, so I repeat, it is capable of providing good nuclear staining. So kung titignan mo, the characteristics of your hydrochloric acid really does not follow the rules that we have in decalcification. It's slow, it causes greater distortion, and again, the good thing about it is that it provides good nuclear staining, unlike for the other acids that we use for decalcification. Okay. Since your hydrochloric acid may destroy your tissue sample or your tissue components, its use in the laboratory is usually for surface decalcification only. Okay, so I already discussed what is surface decalcification, and I mentioned one formulation of hydrochloric acid that you can use for surface decalcification. So one formulation of your hydrochloric acid for surface decalcification is your 10% hydrochloric acid. Okay? So aside from your 10% hydrochloric acid, 1% hydrochloric acid with 70%. Okay, with 70% alcohol can also be utilized for surface decalcification. Okay, so that means for surface decalcification, we can utilize two. I have mentioned two already, two solutions. All right, so apart from surface decalcification, we can also make a formulation out of your hydrochloric acid, which is referred to as your von Ebner's fluid. So your von Ebner's fluid, it contains hydrochloric acid with 36% aqueous sodium chloride. So von Ebner's fluid, this is utilized for teeth and small pieces of bone samples. Okay, for teeth and small pieces of bone samples. All right. Another thing that you have to remember for your hydrochloric acid, it cannot be measured by the chemical test that we use to measure or to determine complete decalcification. Okay. All right. So other acids that you can utilize in the laboratory. So we have your TCA or your trichloroacetic acid. So your trichloroacetic acid, it is considered to be a very slow decalcifying agent, and it is also a weak, okay, weak acid. Since it is very slow, okay, in its action, it is utilized only for minute samples. Okay, it is only utilized for minute samples. All right. So the good thing about your trichloroacetic acid is that it provides good nuclear staining and it does not require any washing out. Okay, why does it not require washing out? This is because the solution that is utilized to remove your TCA is 90%. Nasa inyo ba yan? Wala. Okay. So the solution that is utilized to remove your TCA is 90%. Okay, 90% alcohol. So in particular, in particular, um, we make use of several changes of 90% alcohol. Okay. So again, just like what I have mentioned previously, if a reagent does not require washing out, then the washing solution, or this is because the washing solution that is utilized to remove it is the same reagent that you're going to use in the succeeding step. So after decalcification, what step do you have to perform? We have your dehydration. So in dehydration, the reagent that is utilized is your alcohol, right? So this is like hitting two birds with one stone. You don't have to wash your TCA or to remove your TCA from your tissues because your TCA will be removed when you perform the dehydration process. Okay? Kasi nga, ang ginagamit na washing solution ay 90% alcohol. Okay? It's the same reagent that you're going to use for the dehydration process later. Okay? Yes. So another, we have your Fleming's fluid. All right. So your Fleming's fluid, yes. Okay. Yes, looks familiar or sounds familiar. It is also a fixative. Okay. So Fleming's, it can be used as a fixative and a decalcifying agent. And in the laboratory, we utilize Fleming's fluid for the decalcification of minute samples. All right. So I have mentioned a lot of reagents already that you can use for fixation and decalcification. So ano yung mga yon? Yes, let us try to remember. Okay, number one, formic acid. Okay, another, we have carnoys. Another, we have your bowens. Okay, so in particular, may I just mention that in your carnoys, what will facilitate decalcification is your glacial acetic acid. Sorry, is your glacial acetic acid. In your bowens, on the other hand, what will promote decalcification is the presence of your picric acid. Okay, so tatlo na yon. Formic, Formic, carnoise, Bowens. Your trichloroacetic acid can also be utilized as a fixative and a decalcifying agent. And we have your Flemings. Okay, so I have mentioned 5 already. Formic, carnoise, Bowens, TCA, and your Flemings. Okay? So all of them can be utilized as fixatives and decalcifying agents. Okay? The problem with your Fleming's fluid is that it contains chromic acid, which is considered to be both an environmental hazard and a health hazard. Okay, so your chromic acid being an environmental toxin, would require special protocols for its disposal. Okay, so you cannot just dispose it in your sink. You cannot just throw it away. You have to follow special protocols or procedures with the disposal of your chromic acid. Okay. Apart from that, your chromic acid is also considered as a health hazard. In particular, it is highly corrosive to the skin and to the mucous membranes. Okay, so you have to be very careful when using Fleming's fluid. Okay, so you have to avoid splashing it onto your skin or onto your eyes, onto your mouth, so on and so forth, because it is highly corrosive. Okay, it is highly corrosive. All right, ayan. Of course, you have to wear your PPE. You have to perform it properly. Okay, the procedure, I mean. All right, so next we have your citric acid citrate buffer. Your citric acid citrate buffer, it is maintained at a pH of 4.5. Okay, so the good thing about your citric acid citrate buffer is that it provides excellent nuclear and cytoplasmic staining. Okay, so it provides excellent nuclear and cytoplasmic staining. And apart from that, it does not produce any distortion. Okay, it does not produce any tissue distortion. Okay, so the preservative that is incorporated in your citric acid citrate buffer to maintain its effectiveness is chloroform. Okay, we have chloroform. All right. So before we go to the other ways by which you can perform the decalcification process, may I just mention some of the stains which are utilized after acid decalcification. Remember that one of the steps which will be greatly affected if you perform the decalcification process is your staining. Okay, your staining step. Okay, and so what are the different stains that we can use after acid decalcification? All right. So for the recommended, what is the recommended staining technique again for histology? Yes, correct. We have your hematoxylin and eosin staining technique, or your H&E. However, your H&E is only capable of providing satisfactory results. So that means kung sa grade yan, I think 75 for tuwan-tuwa si ma'am. Okay. At bakit masaya ako? Okay, 75. I think for medtech that is satisfactory already, right? I don't know, me, I'm satisfied with 75. Okay, so for me that's satisfactory. So kung ihahambing natin siya, okay, if we're going to make an analogy out of it. So H&E, it provides satisfactory results. So in medtech grades, that's 75 already. Okay. However, there are some stains which will provide better staining results and are thus recommended after acid decalcification. So what are these? We have your Mason's hematoxylin floxin safran. Okay, that's one staining technique only ha. Please do not hiwa-hiwalay. Anong hiwa-hiwalay sa ano? English? Do not separate it. Do not separate the dyes or the term. Okay, that's one term only. Mason's hematoxylin Mason's hematoxylin floxin safran. That's one term. Okay, and that is one staining technique that is recommended for acid decalcified tissues. Okay, another recommended staining technique is your GEMSA. Okay, GEMSA stain. All right. Yes. So both of these are capable of providing better results as compared to your HNE, which is only 75. Siguro for Masons and GEMSA, 80. Mga ganun ang kaya niya. Okay? All right. So those are the different acid decalcifying solutions that we can use for the removal of your calcium and mineral deposits. Okay, so other ways by which we can perform the decalcification process would be for us to utilize your chelating agents. Okay, so the chelating agent that that we use for histopath is your EDTA. Okay, so I hope you know the name EDTA already. By the way, I will not be requiring you to know the meaning of EDTA because I know that you already know the meaning of EDTA and wala naman akong binibigay na identification, right? So, okay lang yan. Okay, chelating agents. So we all know how your chelating agents work, right? So they work or they sequester your calcium ions or your cations by binding, okay, by forming complexes, okay, with your cations. Specifically in this case, it's your calcium ions. So they form complexes with your calcium ions and are able are able to remove your calcium deposits. All right. So EDTA, the commercial name of EDTA in histopath is your Versine. All right. So I'm sure you have discussed this in your HEMA 1 or in your PRMLS P2. There are two salts of EDTA which are available in the market, right? We have your potassium EDTA and then the other one is your sodium EDTA. Potassium EDTA, so the commercial name is, very good, we have your sequestrine, okay? The sodium salt of EDTA, the commercial name is Versine. So in histopath, we make use of the sodium salt of EDTA. Thus, if it will be asked later on in the board exam, what is the commercial name of EDTA in histopath? Even if you know that sequestrine is also a commercial name, the correct answer is Versine. Kasi Versine lang ang ginagamit natin sa histopath. Okay, it's only the sodium salt that we utilize in histopath. Okay, so that's why the correct answer is Versine. Okay, so your EDTA, this is considered to be a decalcifying agent, and it can also be utilized as a water softener. So remember that when you soften water, what you are doing is to remove, right, the hard minerals which are present in water. That is the process of water softening. And your EDTA is also capable of doing that by forming complexes with these minerals which may be present in water. Okay, so in histopath, EDTA, this is considered to be an excellent bone decalcifying agent, especially if you are going to perform immunohistochemistry later on. Okay, kasi it's not a strong acid, right? So remember that what will destroy your antigens, your surface antigens are your strong acids. Okay? But since EDTA is not a strong acid, it is actually considered to be an excellent decalcifying agent. Yes, decalcifying agent for immunohistochemistry. Okay? So apart from that, other advantages of your EDTA, it does not interfere with staining, and it does not distort tissues and enzymes. So there is an exception to the rule when it comes to your enzymes. Okay? So take note that EDTA, ito lang po. Okay? Take note that EDTA, it can inactivate. Okay? It can inactivate. Saan na yun? Wait a minute. It can inactivate your alkaline phosphatase. Okay? So I repeat, it can inactivate your alkaline phosphatase. Okay, so let me just add that. ALP, alkaline phosphatase. All right. Yes. So you can perform a remedy if, for example, you want to reactivate your alkaline phosphatase. So for the reactivation of your alkaline phosphatase in EDTA, decalcified tissues, we usually add magnesium chloride. Okay, so we usually add magnesium chloride to reactivate your alkaline phosphatase. Okay, to reactivate your alkaline phosphatase. Okay? All right. If you're going to look at the advantages of your EDTA, it actually has a lot of advantages. Okay? Because it's not as detrimental as compared to the acid decalcifying agents that we use in the laboratory. Okay? The problem with your EDTA is that, it would require a long duration for the decalcification process to be complete. Okay, so in particular, for small specimens, it would require 1 to 3 weeks of decalcification. For dense cortical bone, okay, it would require 6 to 8 weeks. Just imagine that. 2 months of performing the decalcification process. Diba? Ang tagal. Okay? So that is the major disadvantage of using EDTA in removing your calcium and your mineral deposits. Okay? So in the laboratory, EDTA, this is available in 2 formulations. Alright. Yes, nahuli si ma'am. Sorry naman. Okay. So it is available in 2 formulations. Just like what I have mentioned, we make use of the sodium salts of EDTA. So we have, okay, what are the 2 formulations? I think it is in your manual. Yes, it is. The first one, we have your 5 to 10% EDTA disodium. Okay. The good thing about your 5 to 10% EDTA disodium is that it is already buffered at the right pH. And what is the pH of your disodium? We have 7 to 7.4. Okay, which is the required pH of the EDTA solution that we use for decalcification. Okay, the other formulation that is utilized is your EDTA tetrasodium. The problem with your EDTA tetrasodium is that it is originally basic. It is originally alkaline. Okay, so you have to adjust the pH of your EDTA tetrasodium to 7.4. And the reagent that we use to adjust the pH of your EDTA tetrasodium is concentrated acetic acid. Okay, so pH adjusted to 7.4 using concentrated acetic acid. Okay. Yes. So balik po tayo doon sa duration. All right. So we all know that in the case of your decalcification, the solution, the decalcifying solution is used up in the process. So that means the effectiveness of your decalcifying solution decreases as the process progresses. Okay, so with that, you have to change. Okay, changing of the solution, you have to change. Okay, changing of the solution is required for the decalcification process. So in the case of EDTA, in the case of EDTA, during the first stages of decalcification, you have to change your EDTA solution every 3 days. Okay, so I repeat, during the early stages of decalcification, you have to change the solution every 3 days. During the final stages of decalcification, you have to change the solution every day. Okay, every day. All right. So one of the most important factor that we have to consider when using your EDTA solution would be the pH of your solution. All right, the pH of your solution. So in particular, very easy, there are only 3 pHs, okay, pH values that you have to be familiar with. We have pH 3, okay, we have pH 3, pH 8, and of course, we have pH 7.4. Okay, so pH 3 at pH 3, calcium binding or cation binding is inhibited at this particular pH. So never, ever, ever utilize a solution with a pH of 3. Okay, so at pH 8, on the other hand, pH 8 provides optimum binding. It provides optimum binding of your EDTA to your cations or to your calcium ions. However, the problem is that alkaline, a high pH, okay, a high pH or an alkaline pH will tend to damage will tend to damage alkaline sensitive protein linkages. Okay, so I repeat, pH 8, it provides optimum binding, but it damages alkaline sensitive protein linkages. Okay, so that's why we do not make use of EDTA solutions with an alkaline pH. Just like in the case of your EDTA tetrasodium. Remember, EDTA tetrasodium, what is the original pH? Alkaline. But we have to adjust the pH because we cannot use an alkaline or a basic solution for decalcification. Otherwise, sorry, the protein linkages that serves to maintain the morphology and the architectural pattern of your tissue components will be destroyed. Okay? And so the best pH for your EDTA solution is at 7 to 7.4. Okay, so at 7 to 7.4, it allows binding, and at this pH or this pH does not damage your tissue components. Okay, it does not damage your tissue components. Okay, so I think I have mentioned alkaline phosphatase a while back already. All right, so what else? EDTA. Wala na yata. Alright, so that is with the use of your EDTA for decalcification. So now let us move on to another method that we can perform to remove your calcium and your mineral deposits. Okay, so the next one, we have your ion exchange resin. Okay, so in the case of your ion exchange resin, there is an additional material that is required. Okay, and what is that? Of course, it's your resin. Okay, so the resin that we use for this method is your ammonium sulfonated polystyrene. Okay, so this is the resin, ammonium sulfonated polystyrene. And take note that in your ion exchange resin, um, there is still a need for you to make use of your acid solution. So in particular, the acid solution that we use for ion exchange resin is formic acid. Okay, formic acid. And the volume that is required, okay, is 20 to 30 times the volume of the sample. Okay, so this is the required volume for ion exchange resin. Okay, for ion exchange resin, we have 20 to 30 times the volume of the sample. All right. So with the use of your formic acid, some references, ang tawag nila sa ion exchange resin is rough. Okay, rough. So some references would refer to this method as rough. Rough stands for resin and formic acid. Okay, resin and formic acid. Okay, rough. All right. Ayan. So how do we perform your ion exchange resin? Ito na naman, mag-drawing na. Okay, so how do we perform your ion exchange resin? So say for example, this is your container. Sorry. Okay, so say for example, wait a minute. Wait a minute. Wait a minute. Wait a minute. Okay, sige. Ulitin natin. Alright, so say for example, this is, ganun pa din eh. This is your container. Okay, so say for example, that's your container. Okay. Yes. Alright. So that's your container. So we you have to incorporate your resin at the bottom portion of your container. So specifically, the required thickness of your resin is 1/2 inch. Okay, 1/2 inch or 0.5 inch. Okay, so that's your resin. So after that, add your formic acid. Okay, so again, how much of your formic acid should you use? We have 20 to 30 times the volume of the sample. Okay, so that's your formic acid. Okay, and how do we suspend again your sample? Okay, so you have to suspend it at the upper portion of your container. Okay, so say for example, that's your sample. All right. So how will your mineral deposits or your calcium deposits be removed using your ion exchange resin? So first thing that will happen in your setup would be the dissolution of your mineral deposits or your calcium deposits. Okay, so this dissolution, this will allow the liberation. This will allow the liberation of calcium or mineral deposits. Okay? Yes. So this will allow, ulit-ulit ka ma'am, this will allow the liberation of your calcium or your mineral deposits. Okay? Particularly the ionized forms of your cations. Okay? So once your cations or your calcium ions are liberated from your calcium sample, the next thing that happens, okay, the next thing that happens is that these ions will be attracted to your resin. Okay, so I repeat, the ions will become attracted to your resin. Okay, kaya nga siya ion exchange resin. You liberate your mineral deposits or your calcium deposits, so they will be liberated as ions or in their ionized forms, and the ions will now be sequestered. Okay, they will now be sequestered by the resin which is found at the bottom of your container. Okay, so I repeat. Ano ba yung sinabi ko? Okay, so resin will sequester, okay, liberated ions. Okay, so nakikita pa ba? Alright, so your ions, your resin will sequester the liberated ions, thereby allowing decalcification to take place. Okay, yes. So in this case, okay, in this case, your uh, your your acid, it is not actually being used up in the process of decalcification because its only function is to liberate or is to free the calcium ions which are present in your sample. Tama ba? Okay. So it is not being used up. It does not react with the liberated calcium ions. And so it is not being used up. So that's why one of the advantages of your ion exchange resin, okay, tingnan nyo doon sa ano nyo. One of the advantages of your ion exchange resin is that it does not require daily changing of your solution. Okay, it does not require the changing of your solution because your solution is able to maintain its effectiveness all throughout the decalcification process. Ako ha? Unlike in the previous methods that we discussed, like for example, in the use of your acids and in the use of your EDTA solutions, both of them, they have to react with the liberated calcium, with the liberated minerals. And so, they are used up in the decalcification process. But since in your RAF or in your ion exchange resin, ang magre-react, tama ba? Okay? What will sequester or remove your calcium, your liberated mineral deposits, your liberated calcium deposits in your solution is your resin. Okay? And so, what you need to reactivate, it's actually your resin and not your acid. Okay, nakuha? Oh man, nakuha. Okay, yan. Yes, very good. All right, so other advantages of your RAF, we have cellular detail is well preserved, and of course, the decalcification is faster. This is in comparison with the use of your formic acid only. Okay, in comparison with the use of your formic acid only. Okay, ayan. So the decalcification process is faster. Okay, so just like what I have mentioned, the one that loses its effectiveness in your RAF is your resin. And so in the laboratory there is a procedure that we can perform in order to reactivate the resin that is utilized for RAF. And what is that? You have to wash your resin in N, normal over 10. Actually, ito hindi ko din talaga maintindihan. I mean si Gregorios, naiintindihan ko ito mismo. Okay? Yeah, sometimes it's very difficult to understand what Gregorios is really trying to tell or to say, okay? Because based on our knowledge in analytical chemistry, N over 10, okay? N over 10, this is actually equal to 1 over 10. Okay? So that's about 0.1 normal. Yan. Diba? It's easier to understand kung if ever Gregorius just mentioned 0.1 normal instead of N over 10. Okay? Yes. So the solution that we use for the washing or for the reactivation of your resin is 0.1 normal hydrochloric acid. And a final washing is to be performed using distilled water. Okay, not tap water because tap water can contain minerals, right? Yes, it can contain minerals. All right. So you have to make use of distilled water for the final washing of your resin in order for it to be reactivated. Okay. So in the laboratory, there are several formulations. Yes, formulations of RAF that we can use. So we have 10% and 20% RAF. Okay. So 10% and 20% RAF, this is utilized for cancellous bone samples. Oh, ano ulit ang cancellous? Okay, yes, correct. We have your spongy bone samples. And the thickness that is required for your spongy bone, it has to be 2 to 3 millimeters thick. Okay, 2 to 3 millimeters thick. This one is immersed in 10 and 20. Okay, 10 or 20% RAF for 2 to 3 hours. Okay, so for thick samples, on the other hand, with thickness, or for samples with the thickness of 5 to 6 millimeters, you can make use of uh, 10 or 20% RAF, and you have to immerse it in this solution, or in this, you have to perform rather decalcification for 4 to 8 hours. Okay, so yan. So another formulation of RAF that we can use is 40%. So 40% RAF, this is utilized for large pieces of dense bone samples. Yan, of dense bone samples. So when we say dense bone samples, we are referring to your cortical or your compact, sorry, or your compact bone samples. Okay, so how do we perform the decalcification of your compact samples using 40% RAF? So you have to immerse it in 40% RAF for 24 hours, and then after which you are going to trim your samples to 3 millimeters thick. Okay, to 3 millimeters thick. And then after that, you have to immerse it again, or you have to perform decalcification again in 40% RAF for another 24 hours. Okay, for another 24 hours. All right? Yes. The problem or the advantages of your decalcification or of your ion exchange resin is that the end point of decalcification is measured or can only be measured by two means. We have physical test and then your X-ray or your radiologic methods or tests. Okay, you cannot make use of your chemical test for your ion exchange resin. Okay, and apart from that, your ion exchange resin, um, another disadvantage would be the formation of your carbon dioxide. Okay, so your carbon dioxide gas, it can, or it is considered rather as an artifact. Okay, yes, and it is related with the use of your ion exchange resin for decalcification. Actually, your EDTA, it is also liable to form your carbon dioxide artifact. Okay, it is a shared or a common disadvantage of the use of EDTA and your ion exchange resin in the laboratory. So both of them may lead to the formation of your carbon dioxide artifacts. Okay. And the last method that we can perform for decalcification is electrophoresis. All right. So your electrophoresis, just like your ion exchange resin, would require also the use of additional materials. And in this case, we are using your electrodes. Okay, we are using your electrodes. Electrophoresis, by the way, this is otherwise referred to as your electrical ionization. Okay, electrical ionization. So with the use of your electrode and your acids, so that means you still need your acid decalcifying solutions. Okay, so the acids that are utilized for electrophoresis, we have 88 or 90% formic acid and concentrated hydrochloric acid. Okay, so there are two acids that you need, formic acid and your concentrated hydrochloric acid. Okay, so again, just like in your ion exchange resin, the purpose of your acid decalcifying solution is to liberate. Okay, it is to liberate the calcium ions or the mineral ions that are present in your tissue sample. All right. So your calcium ions being positively charged, they are referred to as your cations. They will be attracted to the negative electrode. The negative electrode, guys, remember from your clinical chemistry 1, what is the name of your negative electrode? It's your cathode. Okay? So your cations, your positively charged ions, they will be attracted to the negative electrode, which is your cathode. Okay? Yes. So this one is your cathode. Okay? Yes. The problem with your electrophoresis is that it is dependent on stable electricity for the removal of your calcium ions. Okay? So that means you have to be able to provide stable electricity for the entire duration of the decalcification process. Otherwise, this will affect the decalcification process. Okay? So apart from that, another disadvantage of your electrophoresis, since it is an electrolytic method, there is a consequent production of heat. Tama ba? Electrolytic methods, okay? So, there is a consequent production of heat or an increase in temperature. That's why when you perform electrophoresis, you have to be very careful to maintain the temperature of the solution or of the decalcification process at 30 to 45 degrees Celsius only. Okay, so I repeat, you have to maintain the temperature at 30 to 45 degrees Celsius only. Otherwise, again, an increase in temperature will compound, okay, the detrimental effects of your acids. Okay, so those are the different methods that we utilize for the decalcification process. Okay, so while carrying out the decalcification process, it is very important that you have to know if the decalcification process is already complete. Okay, so I repeat, you have to know or you have to establish, yes, you have to establish or you have to determine, ang dami mong sinasabi, ma'am. Okay, you have to determine if the decalcification process is already complete. Okay, so how do we determine if the decalcification process is already complete? There are 3 tests that we can perform. We have your physical test, your radiologic test, and your chemical test. Okay? So again, what is the significance of performing these 3 tests? Wait a minute, i-pause ko lang. Alright, I'm back. Ano, parang hindi ako nawala, ano? Okay, yes. So again, why do we need to test if the calcification is already complete? Why? Okay, yes, very good. Okay, yes, very good. Because we do not want, okay, I do not want, you do not want, we do not want your tissue sample to be in contact with your acid in particular for a prolonged period of time. Okay? So if it is not necessary for this contact to happen, then you have to prevent it from happening. Otherwise, remember, over-treatment in your acid will have consequences, right? Overtreatment in your acid will have consequences. Okay? So prolonged contact of your tissue sample with your acid decalcifying solution will become more detrimental to your tissue sample itself and to the staining of your decalcified tissue sample. Okay? So that's why it's very important for us to determine if complete decalcification is already achieved. Okay? So the first test that we can perform, this is your physical test. Your physical test, this is otherwise referred to as your mechanical test. Okay? So physical test or mechanical, katinang ilong ko talaga. Okay, we have mechanical test. So from the term itself, physical or mechanical, okay? So how do we perform it? We touch, okay? We touch your tissue sample. We bend, we bend your tissue sample in order to determine the consistency of your tissue sample. Okay? We can also prick your tissue sample using a fine needle or a probe. Okay? Yes. So what is the basis of complete decalcification in your physical or your mechanical test? Dito na lang sa taas ha. So our basis for the physical test or mechanical test would be if there is a diminished in consistency, diminished consistency. Okay, diminished consistency. This can be seen if, for example, your tissue sample or your tissue specimen has become softer, okay? If your sample has become flexible, more flexible, so you can bend it already, okay? So when you touch it, it has become softer. So that means complete decalcification is achieved. Okay, so it's a very simple test or procedure that we can perform in the laboratory. Again, the basis would be diminished consistency. The sample has become softer, the sample has become flexible. Okay? Yes. And actually, that's the problem with your physical or your mechanical testing. Why? Because it is a vague. It is considered to be a vague. Okay, malabo. Okay? And it is unreliable. Because you cannot really determine, you cannot really tell. Parang there is no, there is no, ano tawag doon? Anong there is no, I forgot the term, there is no concrete evidence. Hindi substantial. The evidence that you are providing for complete decalcification is not substantial. Okay? Yes. So it is considered to be a vague and unreliable test for complete decalcification. Okay? So apart from that, the problem with your physical or mechanical test is the way we perform this particular test. How do we perform it again? We bend. Okay, we bend. That's one. Bending is one of the ways by which we can perform this test. And when you bend, okay, when you bend or when you touch your tissue sample, so the components which are there might be distorted. So that's the problem. Okay, there is a high probability that you will be distorting some of the tissue components which are present in your sample. Okay? Another is with the use of pricking. Okay? So if you prick your tissue sample, even if you are going to make use of very small needles, okay, or very fine needles, there would always be there would always be the presence of your needle track artifacts. Okay, so I repeat, pricking your tissue sample with fine needle or probe, this will result to the formation of your needle track artifacts. So some of the components, okay, some of the details in your tissue components or your tissue constituents will also be destroyed due to the presence of your needle track artifacts. Okay, yeah, so those are the disadvantages of your physical test. That's why we don't usually perform it in the laboratory, even if it is considered to be a simple test for complete decalcification. Okay, another test that we can perform is your radiologic test. Okay, so your radiologic test. This is otherwise referred to as your X-ray test. Okay, this is otherwise referred to as your X-ray test. And the basis for complete decalcification is the absence of opaque areas. Okay, so I'm pretty sure a lot of you or all of us have experienced um yes, have experienced, or all of us experienced having chest x-rays already, or if we yes, if we have x-rays. Okay, the bone your bones, they would appear as opaque areas. Okay, and the reason why your bones appear as opaque areas is because of the presence of your mineral deposits, particularly your calcium salts. Okay, and it's the same principle that governs the radiologic test for complete decalcification. Okay, so your calcium and your mineral salts will produce opaque areas in your X-ray film. Okay, in your X-ray film. And so, what will indicate complete decalcification would be the absence of your opaque areas. Ako ha? Okay. So the additional equipment that we use for radiologic test, we have your Fixatron and your Kodak X-OMAT X-ray film. Okay, so how do we perform your radiologic tests? Siyempre, magdo-drawing na naman ako. So in your radiologic test, you have here, okay, you have here your X-ray film. Okay, you have here, you have here your X-ray film. Okay, and then on top of your X-ray film is your waterproof polyethylene sheet. Nasaan yun? Okay, the equipment. Wala. Okay. So I repeat, you have here your X-ray film, the red one. And then on top of your X-ray film, right? On top of your X-ish. All right. So on top of your X-ray film is your waterproof, okay? Waterproof polyethylene sheet. Okay, the green one, that's your waterproof polyethylene sheet. Okay, and of course, on top of your waterproof polyethylene sheet, on top of that is your tissue sample. Okay, so you have here your tissue sample. All right, and what do? We have to expose this. Okay, so you have to expose, okay, expose it to X-ray at 30 kilovolts for 1 minute. I think that's in your handout. Wala. All right, so we have to expose your tissue sample at, uh, expose it in X-ray at 30 kilovolts for 1 minute. Okay, 30 kilovolts for 1 minute. All right, so after which you are going to Of course, check your X-ray film for the presence of opaque areas. Okay? So if, for example, opaque areas are present, then it indicates incomplete decalcification. So what do? You have to continue the decalcification process. Okay? You have to continue the decalcification process. Alright? So your radiologic test, so take note, it is not recommended for mercury chloride fixed tissues. Because remember, your mercury chloride, this is a fixative that is recommended for tissue photography. And so, mercury chloride-based fixatives, they will produce opaque areas. So, they will produce radio opacity. Okay? So, say for example, you made use of Heidenhain-Sousa. Okay? You made use of Heidenhain-Sousa as your fixative. Then, if you need to perform decalcification, you cannot perform radiologic test to determine if complete decalcification has been achieved. Because the mercury chloride that is incorporated in your tissues, remember, it's an additive fixative. Tama? Okay, so the mercury chloride that is incorporated in your tissue samples will produce opaque areas. It will produce radio opacity. So even if the decalcification is complete, talagang may opaque areas kang makikita. Okay, so this is not performed for mercury chloride fixed tissues. Right? So apart from that, your radiologic test, okay, it is considered to be the very expensive. Sorry. It is considered to be very expensive, okay, because of the need of additional materials and equipment in the performance of this test. However, take note that your radiologic test, it is considered as the most ideal, most sensitive, and most reliable test out of the three. Okay, so out of the three, siya yung the best. Pero, pinakamahal din. Okay, so you have to weigh, yeah, you have to consider these factors when you want to perform radiologic testing for complete decalcification. Okay, and then the last one, the last test for complete decalcification is your chemical test. Okay, your chemical test. Your chemical test, this is otherwise referred to as your calcium oxalate test. Tanggalin ko nga lang mga mesh. Okay, so this is otherwise referred to as your calcium oxalate test. Okay. Calcium oxalate test. This is considered to be a simple, reliable, and a convenient method for routine procedures. So that means out of the three, the one that is commonly performed in the laboratory is your chemical test. Okay, otherwise referred to as your calcium oxalate test. Okay, calcium oxalate test. So your calcium oxalate test, this involves the precipitation of insoluble salts. Okay, it involves the precipitation of your insoluble salts. So how do we perform your chemical test or your calcium oxalate test? Okay, so first, of course, you have your, okay, so you get a test tube. Okay, so your test tube, you have to, ang sabi niya dyan, alico. Okay, so you have to get alico o alicote, bala ka. So you have to get 5 ml. Okay, so this requires 5 ml, 5 ml of used reagents. Okay, so you get 5 ml of used reagent. So that means used decalcifying solution. And then after that, you have to alkalinize. Kasi what do we usually use for decalcification? Yes, of course, we have your acids. Okay? So you have to alkalinize it with strong ammonia. Okay, so I repeat, you have to alkalinize it with strong ammonia. Yes, I know. The one that's in your module is ammonia water. So actually, for the alkalinization of your used reagent, you can either utilize strong ammonia or ammonia water. Okay, so whichever is available in the laboratory. Yes. So how do we perform alkalinization? How do we perform alkalinization? What litmus paper do we use? Okay, yes, very good. So you have to make use of actually either naman. Yes, either. You have to make use of your litmus paper. So say for example, you make use of your you make use of your blue litmus paper. So upon the addition of your blue litmus paper to your 5 ml used reagent, your blue litmus paper will become red. Tama ba? So if you utilize naman red litmus paper, of course, it will remain red because the reagent that is utilized is an acid. So in order to know that alkalinization is complete, the red color of your litmus paper should turn blue. Okay, so once your litmus paper turns blue, then your alkalinization is complete. Okay, so in the process of alkalinization, dito pa lang, you would be able to observe already if your calcium salts are present or not. Okay, yes. So after alkalinization and precipitate formed. Okay, so aside from the formation of precipitates, you also have to take note of, okay, ano ang positive nito for the presence of your calcium salts. So we have the presence of precipitation, okay. Another observation that will indicate a positive result would be the presence of turbidity, okay, or the presence of cloudiness. So you look for this, okay, evidences. So if it is positive for precipitation, positive for turbidity, or positive for cloudiness, so that means, okay, it is positive for your calcium or your mineral ions, okay, or deposits. So meaning also the decalcification process is incomplete. So I repeat, meaning the decalcification process is incomplete. So what do? You have to change the solution with a new one. Okay, and continue with the decalcification process. All right. So the precipitation, turbidity, or cloudiness in your solution after alkalinization, this is due to the presence of the substance. Okay, so this is, ano ba yun? This is due to the presence of the substance calcium hydroxide. Okay, ano ang calcium? Ca3. Okay, we have calcium hydroxide. Okay, we have calcium hydroxide. All right, ayan. So this is the one that will cause precipitation, turbidity, or cloudiness after alkalinization. Okay, yes. All right. So if, for example, there is no precipitation, turbidity, or cloudiness, if there is no yes, if you were not able to observe this after alkalinization, the next step would be the addition, ay, okay, yeah. So the next step would be the addition of your ammonium oxalate. Okay, so the next step is you add 0.5 ml, yes, 0.5 ml ammonium oxalate or 1% sodium oxalate. So you allow the solution or the mixture to stand for 15 to 30 minutes, and then after which you are going to observe again for the presence of precipitation, turbidity, or cloudiness. Okay? So if for example, there is precipitation, there is turbidity, or there is cloudiness, so it indicates the presence of your calcium. So meaning decalcification is incomplete. Okay? So at this particular point of the chemical test, what will cause the precipitation, turbidity, or cloudiness would be the calcium oxalate that will be formed. Okay, so I repeat, the cause of cloudiness or precipitate or turbidity is the presence of your calcium oxalate. Okay, yes. So say for example, even after the addition of your ammonium oxalate and after standing it for 30 minutes, there is no precipitation, turbidity, or cloudiness. This indicates that the decalcification process is complete and you have to stop. Okay? You have to stop already the decalcification process. Nakuha? Naintindihan ba? Okay. Yes. Yes, dapat po maintindihan natin ito. All right. So in your module, if you go back to your Perennius fluid, okay, if you go back to your Perennius fluid, there is a modified form or a modified chemical test that we perform in the case of your Perennius fluid. Why? Because um, in your Perennius fluid, precipitate will form upon the addition of your ammonia, even if your calcium ions are absent. So that means even if complete decalcification is already achieved, after alkalinization, there would always be precipitates that will form. Okay, so that's the problem with your Perennius fluid. So what can we do? Okay, with that, or what is the modification that was done in your chemical test? So in order to know if a Perennius fluid decalcified tissue is complete already, or if the process is complete, you have to redissolve the precipitates that will be formed with glacial acetic acid. Okay? So after dissolving or redissolving the precipitates, that's the time that you're going to add your ammonium oxalate. Okay, so again, you have to stand for a maximum of 30 minutes. So after standing and you were able to observe for the presence of precipitation, turbidity, or cloudiness, then that really, truly indicates that decalcification is incomplete. Okay, so that indicates that the decalcification process is incomplete. So you have to perform decalcification. If, for example, after 30 minutes, there is no precipitation, turbidity, or cloudiness, then decalcification is complete. Okay? So you will not be able to really tell if decalcification is complete after alkalinization, unlike for the other decalcifying solutions. Kasi magpre-precipitate at magpre-precipitate yan after alkalinization, even in the absence of your calcium ions, even if decalcification is already complete. Okay, that's the problem with your Perennius fluid. All right, so that's why a modification has to be done with the chemical testing, okay, in conjunction with the use of your Perennius fluid. Okay, so I hope you were able to understand how we perform and yes, how we perform and the possible results for the different tests for complete decalcification. Okay, so physical test, ano ang basis natin? Diminished consistency. So that means if your tissue sample has become softer and is already flexible, okay, you can prick it easily. So that means decalcification is complete. What do? You stop the decalcification process. In your radiologic testing, on the other hand, absence of opaque areas, this indicates complete decalcification. What do you have to do? You stop the decalcification process. Okay? For the chemical testing, on the other hand, absence of precipitate, cloudiness, and turbidity, this will indicate complete decalcification. What do? You stop the decalcification process. Okay? So after determining, or yes, after establishing that complete decalcification is already achieved, the next thing that you have to perform is your post-decalcification treatment. Because again, remember that your your decalcifying agents may still be present in your tissue samples in excess amounts. So the excess decalcifying agents in your tissues, you have to remove them. Okay? So otherwise, there will be an unduly or unwarranted, charot, okay, unwarranted or unneeded exposure of your tissue sample to your acid solutions or to your decalcifying solutions. Okay? So how do we remove your decalcifying solutions? We perform washing out, or we can also perform neutralization. Okay, so we can perform washing out or we can perform neutralization. Okay. Yes. So washing out, we just wash it in water. Okay, water rinsing lang ito. So depending upon the size of your sample, so for small samples, we usually rinse it in water for 30 minutes. Okay, so we rinse it in water for 30 minutes. Okay, yes, 30 minutes for small samples. For larger samples, you have to perform water rinsing for 1 to 4 hours. And for small needle biopsies, you just perform quick rinsing and blotting. Okay, so for the neutralization naman of your acids, we make use of alkaline or basic solutions. So examples would include your 2% lithium carbonate. You can also make use of 1% aqueous lithium carbonate, okay? Or 5 to 10%. Yes, 5 to 10% aqueous sodium bicarbonate. So another, you can also make use of 5% sodium sulfate. Okay, so yun yung mga ginagamit. 1% lithium carbonate, 1% aqueous lithium carbonate, 2% lithium carbonate, 5 to 10% aqueous sodium bicarbonate, and 5% sodium sulfate. Okay? 5% sodium sulfate. May nakalimutan ba ako? Okay, wala. Alright. Ayan. Another would be the post-decalcification of your frozen sections. So you have to wash it thoroughly in water, okay? And the storage of your frozen sections would require an additional reagent. So in particular, storage may be in or with the use of your formol saline with 15% sucrose. And then another storage solution that you can use for your frozen section, we have phosphate buffered saline with 15 to 20% sucrose. Okay, and storage of your frozen sections is at 4 degrees Celsius. Okay, at 4 degrees Celsius. Another, if you make use of your EDTA for decalcification, you have to wash it in water, never in alcohol. Okay, so I repeat, you have to wash it in water, never in alcohol. Why? Because the use of alcohol as a washing solution for EDTA, this will result to the formation of your precipitates. Okay, so I repeat, this will result to the formation of your precipitates. Okay, actually, this is contrary naman with your acids, especially if you are utilizing nitric acid formulations. Okay? So the rule for our acids, or in particular, we have our nitric acid solutions. What is the rule for our nitric acid solutions? Wash in alcohol. Okay? Wash in alcohol, never in water. Okay? Why? Because, okay, because since your, I'm sorry, because, okay, because acid, okay, plus water, so this will result to swelling of your cells. Okay, so acid plus water, this will result to the swelling of your cells. Okay, sa EDTA, baliktad. EDTA, wash in water, never in alcohol. Why? Because EDTA plus alcohol will result to precipitate formation. Okay? So for the storage of your EDTA decalcified samples, it has to be in formal saline or phosphate buffered saline without sucrose. Okay? Without sucrose, contrary contrary to what is required for your frozen sections. Walang sucrose ito ha, no sucrose. Okay? Yes, so those are the different neutralization and washing required for your decalcified tissue samples. Okay? So another post-decalcification treatment that we can perform is tissue softening. Okay? So when we say tissue softening, of course, it would require the use of your tissue softeners. Okay? So when do we perform tissue softening? So tissue softening is performed for unduly hard tissue samples that require decalcification. Okay? That require decalcification. And of course, since they are unduly hard tissue samples, they would also require tissue softening. So tissue softening, this will prevent damage to your microtome, particularly to your microtome knife. Okay, so what are the different tissue softeners that we can use? We can use Perennius fluid as a tissue softener. So in particular, tissue softening using Perennius fluid is performed by immersing your decalcified tissue samples in Perennius fluid for 12 to 24 hours. Okay, so 12 tissue softening, we have 12 to 24 hours. Okay? So actually, your Perennius fluid, it can also be used for surface decalcification. Okay? It can also be utilized for surface decalcification. Okay? So surface decalcification, using your Perennius fluid, you have to, okay, you have to allow your surface block to be in contact with a cotton or a gauze that has been soaked in your Perennius fluid for 1 to 2 hours. Okay? So pag surface decalcification naman, we have the duration is 1 to 2 hours. Okay? So let me check. Ay, wala na. Nawala. Okay, 1 to 2 hours. All right? So how many reagents can we use for surface decalcification? We have 3. Okay? 10% hydrochloric acid, 1% hydrochloric acid, and 70% alcohol, and your Perennius fluid. Okay? So apart from your Perennius fluid, we can also make use of 4% aqueous phenol. This is the same reagent that we use for Lendrum's method, if you can still remember. So Lendrum's method, saan siya ginagamit? For the softening of your hard tissues, right? In fixation. Okay, so it's the same reagent, 4% aqueous phenol. Okay. Another, we can also make use of your 2% hydrochloric acid and your 1% hydrochloric acid in 70% alcohol. So that means your 1% hydrochloric acid in 70% alcohol, it can be used for both surface decalcification and as a tissue softener, just like your Perennius fluid. Okay? Yes. And then lastly, we have Moliflex. This is a commercial name or a manufacturer name or a trade name. Okay. And your Moliflex, this is utilized for tissue softening also. Okay. So you just have to be careful because your Moliflex, this will make your tissues appear swollen and soapy. Okay, so I repeat, after tissue softening in your Moliflex, your tissue samples will appear swollen and soapy. However, do not be, ano yun, wag kang kabahan. Anong kabahan sa English? I forgot. Okay? So do not be shocked. Do not panic. Okay? So do not panic because even if your tissues will appear swollen and soapy, this will not have any deleterious effect or detrimental effect to your tissues. Right? So that is our last. Okay, that is the last discussion for decalcification. I know, may utang pa ako. Okay, yes, I know may utang pa ako na last portion ng fixation. Yes, I will provide that. But inuna ko to because this will be the coverage of your last quiz in his site lecture this coming Thursday. Okay, so I'll see you again in my next video. Okay, I hope you learned a lot. Bye. Bye.